output which is generated directly. So we need to review it. We need to be careful around cleaning it so that the sanitized data is only being utilized or the output. IP infringement, again, this starts from the base whenever we are working on any models. If we are utilizing any AI tools to create a program, we need to ensure that we follow the accountability, explainability, and transparency process. uh, at every point, we need to have a check. We need to ensure that we have proper audit trails as to have a complete picture from where we got the data, whether we had the access rights, and whether it is being used as per the agreed terms. And lastly, misinformation and manipulation. I'm sure we have a lot of examples around this. Uh, the content which is created by AI is quite impactful, but whether it is right or not is something that we need to be careful about. Just because it is compelling, when we read it and we find it compelling, doesn't mean that it is correct. A lot of misinformation and manipulation of data is being practiced by utilizing these powerful AI tools. Same goes with modifying visual content and also audio and other formats. So yeah, all in all, we have enormous value while utilizing the AI tools, but we also need to understand and handle the pitfalls associated with this particular technology. Any feedback or comment on this, or else we can move on. All right. In today's session, we are uh, covering the uh, basic concept of what exactly sustainability is and what are the environmental challenges when we deep dive under the sustainability domain. We will be running through a quick introduction about the artificial intelligence, the basics, and also then moving on to the environmental applications. Then we have overview about the typical AI solutions that are being predominantly used into the industry for reducing the environmental impact. I have curated specific case studies for the industry. We will discuss around that. Lastly, we will have a discussion around the challenges, ethics, and the future of AI for sustainability. So yeah, let's start the journey. The first and foremost topic is to understand sustainability and environmental challenges. I think we are aware about the three pillars on which the concept of sustainability rests. The shared definition is the means of fulfilling the current needs without harming the future generations and their ability to meet theirs in future. The key three pillars that we discuss around when we are talking about sustainability, it's the environmental protection, the economic development, achieving balanced economic development, and also the social equity that supports the thriving of communities. So these are the three key principles around which the sustainability aspect is being discussed. And whatever areas that we are going to touch upon, uh, either as creating awareness or practically providing solutions, it will be built around these three pillars. So if we move on to the environmental aspect, which is this particular session's key focus area, uh, we talk about climate change impact. We also talk about biodiversity loss. Uh, and all these are quite correlated. We have the pollution and resource depletion aspect, and also the habitat destruction, wherein the entire area or the biodiversity is getting affected because the very region wherein they have sustained for quite some time has been impacted quite deeply. Uh, Climate change is something that we hear day in, day out. Biodiversity loss is something which we do not come across in the day-to-day journey. But when we are talking about the industrial scale, it is quite impactful when we are talking about the energy aspect, the fossil fuel production, the utilization of renewable energies. This is one of the areas which is quite challenging to proceed, and it is directly related to the habitat destruction as well. Uh, so, if we are moving into a a more defined approach, because if we just rely on the basic fundamentals of sustainability, everyone will think of it from a very different perspective. The goals which they will set might be varying, and there won't be a consensus. So, realizing this particular aspect, in 2015, the United Nations adopted the Sustainable Development Agenda, which was broadly split into 17 well-defined areas and goals. And this has formed the basis under which the sustainability targets are set, not only for industry level, but also for governments to act upon, for institutions to devise their policy, and for individuals to plan their growth accordingly. So they are broadly covering all the aspects or the three pillars, that is the economic development, the social equity, and environmental impact. So uh, I won't be touching upon each of the goals, but as we move forward, we can see that there are around six goals which are directly linked to the sustainability environmental impact aspect of under the sustainability part, and there are a couple of goals which are indirectly linked, but we can also target to utilize these definitions to help improve our sustainability commitment. So uh, if we specifically look at goal number 13, which is related to climate action, there is a broad term definition which has been put across under the greenhouse gas protocol. This is the goal which most of the industry people are concerned about when it comes to dealing with engineering design and optimizing the processes. So, under the GHG protocol, as it is called, they have categorized the emissions under three scopes. One is the direct emissions, which are basically the emissions coming out of a production facility and directly under the control of the source and owned and controlled by the organization. The scope two relates to the indirect energy emissions. So, for example, if there is a company which is providing only engineering services or services which does not involve production, uh, for them the scope one is not applicable, but they have to also relate to the scope two, which is the way they are procuring the energy to meet their demands, the way they are utilizing the resources and sourcing the uh, or rather consuming the energy and its sourcing. And lastly is the scope three, which are the other indirect emissions. This cover the broader aspect of the travel involved, the supply chain of all the goods that are being procured for the consumption, and also the way the people are commuting. If we have to deep dive, then the way the people commute and so on. So it is being observed. It is observed that Scope 3 frequently accounts for 70 to 90% of a company's total carbon footprint, but it is not I would say, a firm rule, but this is a general observation when we compare the overall emissions that are coming out of a particular organization, if it is a company. So primarily when we are dealing with the engineering aspect, as I said, A lot of times the customers look into the direct emissions part and reach out to the engineering companies. For scope 2, they deep dive internally. And for scope 3, again, they reach out to consultants who can help them streamline on the indirect emissions. Right. I am not sure if, yeah, okay. So, moving on, once we have this particular understanding about the way the sustainability conversation is framed and the way we are approaching it on the industrial level, we can deep dive into understanding the role of technology before we discuss about AI as a technology in general. So, uh, primarily, the way technology has been utilized to address environmental issues is about uh, first and foremost, enhanced data collection. Whenever we are talking about reducing a particular emission level, or we are talking about optimizing or improving the processes, we need to look into a lot of historical data. We need to study the existing processes, and we also need to look at the governing requirements set forth by the government or as well as the organization itself. So when we look into the historical data, it is a huge amount of data, and we have been utilizing technology to collect the data more accurately as the sensors grow powerful, more accurate. A lot of data is being generated, and we need to have certain technologies in place to analyze that particular data to also maintain it in a proper format so that it is we are able to interpret it to the necessary to gain the necessary outcome. Secondly, we have been utilizing technology and AI in particular for resource optimization. When we say resource optimization, it is related to uh, properly planning the utilization and uh, getting the raw material for a particular plant, planning the utility requirements, planning the waste management techniques, and also supporting the overall consumption of natural resources or optimizing the consumption so that we are able to contribute to the sustainability efforts. Lastly, is about predicting the environmental changes. Again, environmental models are something which rely on years and decades of data, which is being continuously fed. But as is the case with any dynamic model, the rapid growth of industrialization, the increase in consumption of particular resources, and the trends, the way the society improves, the standard of living is improving, the way of consumption and the uh, various materials which are being consumed in day-to-day life also keep on changing. So it's quite difficult to keep a track of all the parameters and feeding into the traditional models. So today, by utilizing AI, we are able to bridge that particular gap, and we are able to provide better predictions, which are more relatable to the actual scenarios. So yeah, that's about the technology part and introduction to the sustainability aspect. Before moving on to the next section, I would like to check if anyone would like to have a conversation around any of the topics we discussed or provide a feedback. Right, going on. I hope I'm audible. I'm not able to see this screen. So,
Yes, you're audible.
Yeah. All right. So let's deep dive into the artificial intelligence aspect, the application of AI technologies. But before we deep dive, let's understand some of the fundamental concepts and the contents associated with AI tools. I am sure these points must have been discussed when the introduction, but I would just like to have a short recap. There are four primary technologies or components which are associated with AI tools. The first is about machine learning. This is basically the type of programs wherein the system learn based on the data which is being provided, and uh, it analyzes patterns. A lot of data is fed. The algorithm analyzes a various set of data. It tries to find the pattern, and then it tries to make a prediction. It might be simple experiments like feeding in a lot of images related to a particular animal, and then asking a question by providing a sample image, try to identify this particular animal. The next aspect, which is more advanced, is neural networks. So this is basically derived. The inspiration is derived from the way the human brain works. It will recognize complex patterns and relationships in a data. It will try and solve the complex equations associated with it, and it will help provide data based on a particular problem statement that we are uh, providing it to solve. Third is the natural language processing, the NLP platform, which we typically use. Uh, uh, ChatGPT and all are built around this premise. Uh, it enables machines to understand, interpret, and generate human language. And these are primarily used for content creation, for analyzing uh, a video, the audio from a particular meeting, for example, and it will create a transcript, and it will also be able to create audio from a particular script by certain commands, which we can provide depending on the way it has to generate. Lastly, it's the computer vision. It is basically the uh, component wherein we are utilizing images and visual information from the world, uh, from various sectors, and asking it to analyze, interpret based on the background learning that it has had. We will touch upon all these technologies which are associated under the AI domain when we are discussing about the case studies. Uh, so it will be helpful to understand how exactly the technologies are being utilized, because it might be quite difficult to make a choice of the direction in which or the particular specific AI tool that we need to utilize for a particular case study. So some of the use cases for AI in environmental solutions is predictive analytics, wherein for example, we can utilize it to forecast climate trends. Also, we can use it to analyze the production pattern for a particular plant. And this is again based on the backend data that we are utilizing to train that particular model. Automated monitoring is a concept wherein we can devise or utilize the AI tool which is trained on certain aspects. For example, the shape of a particular object that is coming across the assembly line. Ask it to monitor and raise alarms in case there are any particular changes that are being found. Similarly, for environmental related aspects, we can utilize it to monitor the broader changes that are being observed, and the data which is being captured, for example, from the the wind speed, the humidity ratings, and also the water levels in a particular reservoir. So we can utilize it to monitor the changes. Optimization algorithms are typically used for resource management, wherein, as we touched upon, the raw material consumption, the utility consumption, and the way the logistics are planned. Uh, those particular parameters are fed into the model, and then the optimum way to address the sourcing, the consumption, and the supply of the finished products are being looked into. For uh, example, if we are looking into a very conventional way of working, uh, there will be a team which will look into the raw material consumption part and the supply chain aspect of that. There will be a different team which typically will look into the operations and the production targets. And there will be a separate team who is working into the uh, who is looking into the uh, sorry, yeah, the supply of the finished products to the market. But if we are utilizing AI tool, it can holistically look at all three processes and optimize the way these things are planned so that the lead time is reduced. We are effectively managing the resource consumption and effectively providing the product to the market, which will eventually lead into the reduction of the emissions across the respective scopes. So, some of the benefits and limitations of AI for sustainability are efficiency and scalability. Let's start with the benefits. First and foremost is the efficiency and scalability. Second is data-driven insights, wherein we can utilize the huge amount of data that is being generated and that is being made available every day uh, to gain proper insights rather than cases wherein there are possibilities of human errors or being missing out on certain key data points. Some of the challenges and ethical concerns are around limitations related to data quality issue because when we talk about AI, when we talk about particular models, uh, the way that particular model is trained, the way that particular model is being uh, enhanced to rectify its errors, the number of checkpoints that are being in this that are being followed, it all adds up to the quality issue. And we need to understand that if a particular model is trained for a particular purpose, we cannot expect to get good results or correct results if we are utilizing it for some other purpose. So, lastly, I would say that as we move forward, we will understand that it's not something that can be done by one particular discipline, but a lot of individual as well as group inputs from across the domains need to go into a particular model to be successful. So, yeah, that's with regards to the overview of AI technology. Now, when we are looking into specific solutions, we will be initially touching upon the aspect of certain cases wherein or certain domains wherein we are utilizing these tools, and subsequently we will deep dive into the case studies. So, climate change prediction and mitigation is one of the core areas of uh, reducing the impact on environment. This is the area wherein a lot of models, AI models are being built. Again, there is no such concept of one size fits all. So uh, a lot of trial and error goes into uh, improving the output of a particular model, and hence the AI the technology or the tool that is being utilized might be customized for each of the cases on a individual basis. So yeah, advanced climate forecasting AI models analyze the vast data sets and help increase the uh, quality of the prediction so that the policies around the agricultural aspect or the water management aspects can be planned accordingly. Policy development support, again, if we have proper predictions, if we have a good quality production predictions around weather and climate activities, it is going to help us devise a stronger policy, something that we can rely upon, and the implementation becomes quite effective. Uh, so we need to adapt to these data-driven insights, and we need to be careful about collecting the right data at the right point of time. Lastly, it's about reducing greenhouse emissions. This is where the optimization of the production processes, the scope one, scope two, and scope three aspects come into picture. And we need to be quite uh, thoughtful about the way we are planning the entire facility or when we are going to approach a particular aspect to be looking into the the GHG protocols at right from the beginning of the stage itself. Right. We have the smart resource management and energy efficiency aspect, wherein it is again a key component when it comes to reducing the environmental impact of various processes. So some of the key areas is utilizing AI tools for building energy use. We have cases wherein the smart meters, which are being installed as part of urbanization and smart city initiatives, are quite helpful in collecting the data, which is again fed into a particular AI model to enhance the predictions of the demand and thus planning the electricity consumption, the heating requirements, the other utilities that are being provided as part of the uh, program. Transportation is another area. A lot of efforts are going into fleet management, utilizing AI for fleet management, which eventually has a positive impact in reducing the energy consumption, the fuel consumption. Also, one of the aspects is moving the mobility, planning to move the mobility options towards electric vehicles and thus reducing the overall dependency on fossil fuels. Uh, Industrial energy efficiency is the third aspect wherein the AI tools, as we discussed, are quite effectively being utilized to understand the specific requirement of that particular plant and the setup and or asset and improve the overall efficiency so as to reduce the utility costs and also effectively reduce the emissions. So some of the initiatives will be moving away from uh, traditional DG sets to electrical or rather gas generator turbines. And if we have some waste heat available, then optimizing that drain, which we have been doing it, but now AI helps to further improve based on the changes that have happened in the asset post the optimization um, activity that had taken place. So we will come across certain cases related to digital twins and also the IoT aspect, wherein a lot of accurate data is being generated, and we are utilizing those to effectively clubbing with the AI tools to effectively improve on and deliver on the sustainability as soon as possible. So we have also cases wherein the intelligence tools are being utilized to address the biodiversity angle or the aspect of the environment. We have cases of real-time wildlife tracking. Initially, the tagging of wildlife has been done since quite some time, but it used to we used to rely on manual monitoring. But the use of AI sensors and AI-based data management has helped us to monitor these without any human dependency, and which has helped us to quite be more efficient. Image recognition technology is something that we are utilizing on the urban level as well, and certain species which are being, uh, for example, if there is a forest area associated with the urban management, so we can utilize certain AI-based image recognition technology at the outskirts or the perimeter fences, so that we can try uh, address any wildlife crossing into unnecessary habitat areas. Lastly, conservation and biodiversity. It is the area wherein AI insights have enabled us to uh, plan and improve the conservation efforts, thus helping us to protect the biodiversity. Some of the examples might be related to areas wherein there was industrial accident, and which might have led to the contamination of a water resource in that particular area. So by utilizing AI monitoring techniques, either related to the checking of the contamination level of the resource of the reservoir, as well as by utilizing the image recognition technology to monitor the visual changes, we can improve the conservation activities, and we can also reduce the overall time that is required to address a particular situation in this case. So, some of the pointers that we need to look into before we deep dive into the case studies is AI is the tool that enables us to make data driven decisions. It is there to improve the delivery or to lead our efforts or fast track our efforts to meet the sustainability commitments. Uh, how we are doing it is by reducing the energy usage, emissions, and waste. When we are talking specifically from the industrial aspect, we need to complement the traditional process models with the predictive capabilities, because when we look into the conventional models which are based on heavy data, the uh, idea of human based prediction has its own shortcomings, wherein we might miss out on certain key parameters and the prediction might be skewed. So, lastly, supporting real-time monitoring and optimization of chemical processes. So, when we look into the industrial aspect, a lot of the engineers will be working in the industry. So even when we're looking from the optimization of the processes point of view, AI can be much effective tool. So one of the examples that we can cite is about the process optimization in refineries. has been found to further reduce the energy consumption by 5 to 10%. And this has been achieved by predictive control, which is driven by the IoT, the advanced sensor based data collection, as well as the digital twin and other similar technologies, clubbing with the AI tools in the backend. Now, the one of the aspects is when we are talking from the faculty point of view is about what's the relevance to chemical engineering. This is something which I have added so that we are able to have a conversation or drive a particular uh, conversation in the direction of how we can utilize it or how we can have a focused approach. So, process modeling based on first principle, that is physical models, that is mass balance, heat balance, momentum balance. These are some areas which we typically approach, and it goes into the rigorous calculations loop. But uh, today, with the addition of AI, the output has quite improved. We are able to gain insights into areas which we were physically not able to do it earlier. Uh, we can discuss about smart optimization of various units uh, or a particular plant as a whole, depending on the how robust that particular AI model is. Uh, we can support advanced research in green chemistry and sustainable processes. We can utilize that to have a novel approach to a particular complex chemical reaction, for example, which has uh, emissions related products as part of its output, and we can optimize it or utilize AI to scale it up further. Now, I won't touch upon the generic example here. Environmental challenges that are effectively being addressed by the utilization of AI technology are around high energy consumption, greenhouse gas, GHG protocols, resource that is water and wastewater treatment, uh, the waste generation aspect, and the resource insufficiency. Uh, we have quite a few examples wherein water scarcity has been one of the prime challenges when it comes to moving forward with a particular industrial plant. So, by utilizing AI and available data, we can definitely address these aspects, the water and the energy availability aspects, right at the beginning of the project stage, that is when it is in the concept and the feasibility stage. So that the overall requirement of resources and utilities is quite optimum by the time it goes into the detailing phase and the actual implementation phase. Uh, again, this is a quick overview about the various components of AI that we had discussed. So, if you have to look into it on the product terms, AI is the system that mimics intelligent decision making. There are various types of AI tools that are available as part of the uh, industry setup. So we need to understand the requirement and the type of AI, the fundamental principle on which that particular AI system is built, so that we can utilize it to enhance our problem solving related to environmental impact. Uh, Data driven versus first principle models. This is the area wherein we also look into the aspect as we discussed why AI is coming in handy. The traditional models, that is the first principle models, are based on mass, energy, and momentum balances. And these are essential to approve a particular design to start. Uh, they are utilized as a starting point for any design and any uh, decision making aspect. But data driven insights are, or data driven models are the models which learn directly from the performance of a particular facility. So, if we are talking about emissions from the industrial perspective, data driven models will be able to predict the real time changes, the requirements, and thus help us to arrive or understand the reason behind a particular incident. Uh, Although the AI models are quite robust and they are able to handle the complex and nonlinear processes efficiently, the best approach is having the hybrid models in place wherein we start with the first principles. We start collecting the data and then we integrate the AI to further enhance our decision making. Uh, One of the key aspects that needs to be understood is when it comes to engineering is the data that we need to collect to have a successful AI implementation, AI-driven implementation. So we need today we have a lot of improvement in technologies. The accuracy has been substantially upgraded for the data that is being collected out of the sensors, the temperature, pressure, flow, composition, and other aspects. So we need to keep in mind that the historical data, which predates the modern sensors, might have certain inefficiencies or certain error associated with it. So we need to factor in that. And then, built on the modern data points, we can have a robust AI model, which can help us into improving the way we are approaching the emissions related aspect. Secondly, when we are talking about the climatic models, the climate change or climate prediction models, weather prediction models, the same thing applies. Today, we have a lot of accurate sensors, so we need to account, we can utilize AI tools not just to predict the future events or the way that particular weather pattern is going to evolve, but we can also take a step back, utilize the AI tools to find the error factor in the old data that was collected, and thus we can improve the overall prediction quality of the models. So we can also focus on fault detection, which helps in predictive maintenance and environmental compliance related aspects. All right. I think yeah, that's fine. Great. So, any pointers, any feedback on the content so far? Any questions or any points we need to discuss before we deep dive into the case studies?
So there is a question in chat box. How exactly AI helps in scalability?
Sorry.
How exactly AI helps in scalability?
Yes. So, when we are looking into the scalability aspect, we need to understand that. Uh, okay, let's take an example that we are working on a particular product. We have a chemical reaction which we are basing our entire process on, and we have certain limitations for that particular uh, reaction, its components. And when we are scaling it up, uh, of course, on the pilot level, it might seem quite feasible. But when we are scaling it up, the economics, the raw material requirement, the production, the off specs, those particular factors come into picture. So we cannot utilize just the first principle models and just keep on scaling up that particular process. We can utilize the AI tools, which can help us either by finding out ways to utilize the off specs and further improve the process, or we can also find out certain steps, intermediate steps, wherein we can utilize the what is considered as off spec for a particular reaction. We can further treat that particular product and improve the overall cost efficiency of that particular process.
Okay, thank you.
Yeah. All right. If that's it, then we will move into the case studies. So, in general, we'll be discussing about the AI application in renewable energy optimization. So, AI algorithms are quite frequently being used for weather forecasting. We just discussed a particular case. Operational adjustments, whenever we are talking about the solar panels or the utilization of windmills, uh, we need to take into account the solar movement, the wind patterns that are associated that have a critical impact on the energy generation. So earlier we had certain fixed models based which were derived from uh, overall understanding of the sun solar movement, the sun moving across the sky. But we may not be able to take into consideration the weather pattern associated. So today with AI, we are able to factor in multiple conditions, multiple components, and we are able to maximize the energy that is being generated uh, from the renewable sources as well. Waste management and recycling innovations. At times, we do feel that this particular area may not be. For example, utilizing AI for sorting is something which may not be quite impactful for the sustainability aspect. But when we deep dive, we look at the amount of waste that is being generated just because of not so efficient sorting techniques or the amount of rework that is needed. So this becomes quite impactful. So we have AI systems which utilize, say, the vision technology or the visual monitoring part uh, or other tool, and also combined with various data sensor inputs. It can help us in sorting and reduce the overall waste. And secondly, it's about the landfill waste. We have utilized AI tools for reducing the landfill waste by increasing or monitoring the recycling aspect and material recovery aspect. Uh, Circular economy is another area wherein we have created impact by innovatively recycling various materials which earlier were quite difficult to address, especially when it comes to waste material extraction in the mining domain. Uh, the other aspect is the agriculture, wherein AI technologies are continuously monitoring the soil conditions, the optimal health is being ensured, and any change in the irrigation pattern or any change in the utilization of fertilizer that needs to be done, that is being predicted and being done by the use of AI models. Again, crop yield prediction. This is an area which traditionally used to rely a lot on the data that was captured uh, in the books, but now it can be managed. New insights can be gained by utilizing certain tools, and the data that is being that is being collected from the various sensors and equipments, so that the farmers can plan it. And also the prevalent market requirements. I think, yeah. So now we move into particular specific cases wherein have split the problem, defined the AI approach that can be taken, how we implement it, what is the impact, and why, what is the learning rate. So these case studies again are from the point of view that we can utilize it, and even uh, can be discussed with students, so that based on the fundamentals that are being taught, they can take up a simple problem, they can have this approach and uh, reach a particular solution. So I personally find this particular approach quite effective, because it is how we can break down a particular problem and understand the base requirement, so that we arrive at the right principle solution. Yeah. So the first is about energy optimization in a particular refinery setup. So a lot of energy is being consumed in the reactors and separation units. Traditional control strategies struggle with non-linear behavior, and we rely on certain guidelines which are part of the operations manual. Again, they have a very linear approach, and we have the trial and error method, wherein let's try this, look at the impact, or try this, have a look. So the AI approach is quite refined in this particular case. We have machine learning models which are trained on the historical process data. Now, when I say historical process data, we need to understand that there are two aspects. Either we will have a very specific model which is trained on that particular plant's data, or we also have certain robust models which are taking into consideration uh, the data from similar facilities within the region, so that we get to understand, and there is a broader scope of analysis that can be done. So based on the ML models, we can utilize AI-based predictive control um, pathway to optimize the operating conditions. And similarly, there have been cases wherein we are utilizing the AI approach to predict the fouling, or improve the fouling in heat exchanger related predictions, thus improving the overall energy efficiency. Now, some of the suggested implementations were the reactor temperature and feed ratio optimization, again based on the ML model, the distillation column energy minimization through a AI-driven reflex control. And the third part is the predictive models to schedule heat exchanger cleaning. So the AI was utilized in these particular aspects, and the overall impact will be around 5 to 15% reduction in energy consumption, lower steam and electricity usages, and CO2 uh, emission reduction as well from the utilities. So again, this is a uh, example which utilizes the hybrid model approach, wherein we have the physical models as well as AI to talk it to have a better outcome. The second case study is about emission prediction and reduction for the uh, VOC emissions that are coming out of a particular plant. These are again a case study wherein, depending on the environmental regulations, we need to monitor and uh, control the CO2, NOx, and SOx emissions in real time. When it comes to when we talk about real time, again, it's not possible with the physical models or the traditional approach that we have, because we have a lot of operators involved. We have shifts. We have different understandings of the parameters. We have changes in the operation manuals. We have changes, real time changes that are happening in the plant. So it's quite difficult for our human based tracking and optimization. So that is where a baseline ML model, which helps us predict the emissions using the real time operating parameters, comes into picture. We can have we can train the model to raise alarms and also highlight certain discrepancies or any variations beyond a particular point, and without human intervention. And we can integrate with the this particular setup with the CMS system of the plant to have a autonomous loop in action with minimal human intervention, or human intervention at the right point of time rather than continuously tracking. So again, it helps us reduce the regulatory violations. It helps us lower the greenhouse gas and pollutant emissions, improved environmental compliance, and moreover, it also helps us optimize uh, or optimum utilization of the human resources, wherein the engineers and the technologists can focus on improving the process rather than getting involved in the uh, day-to-day tracking of the or continuous tracking of these parameters. We have a similar case study when it comes to wastewater treatment. So a lot of water-intensive chemical industries face challenges in maintaining the treatment efficiency. Uh, we also require quite a few chemicals and supplies to ensure the right water treatment approach. So we can utilize or train the ML models to predict the treatment performance. We have traditionally been utilizing the BOD, COD, and the total solids uh, parameters. So we can feed that into a model. We can train it to a particular requirement for the level and ask it to track it for us and provide fault detections in the treatment if at all detected. So uh, having a AI layer over and above the safety controls or the particular interlocks definitely helps in avoiding or reducing the chances of a particular hazard from a safety point of view. It also helps us improve in the energy consumption, and uh, if we are utilizing it to track the raw material requirement and the output quality, uh, it will definitely help us lower the chemical usage and improve on the water quality, eventually leading to the meeting of the sustainability goals. Another case study is about waste minimization and circular economy applications. Now, this is more on the generic aspects because a lot of chemical processes generate large volumes of solid liquid waste, often due to inefficiencies or off-spec production. One of the other criteria or reasons is the change in the feed quality, which often leads to plant upset. Required product quality might change or degrade. So we need to look into the optimization of the entire process again. So it's quite energy intensive process. So we can utilize AI. We can train the model to provide a yield and quality prediction. The waste streams can be characterized, and the data analytics aspect of the AI can be utilized to further optimize. And as I discussed, if we want to further improve on the quality or the cost effectiveness, we can look into the byproduct recovery as well. So again, it leads to reduced waste generation. We can improve the material inefficiencies and enhance the circular economy practices. Uh, this is another example wherein if we are finding it difficult to address a particular problem with the existing methods or existing resources available, we can utilize AI. Again, banking upon the machine learning models to predict the properties of the chemicals and materials. We can ask it to predict the best suitable material that can be utilized, uh, the best possible combination of materials, and we can accelerate the screening of sustainable alternatives because uh, if we are solving it on a human level, we have a very conventional approach. We will be limited by the understanding that we have of that particular uh, domain and rely on our network if possible. But when we open it to the AI approach, we will be able to gain access to compare it quite huge amount of computational power and simultaneously solve multiple fact. We can factor in multiple requirements, and it is able to provide us with the most optimum solution. So we have areas of application wherein which involve predicting the usage of hazardous chemicals, uh, properly planning the supply chain so as to uh, ensure that the material reaches the site at the uh, best possible time, not too early, not late, so that the space is optimized. We can manage the utility requirements accordingly, and it improves on the lead time as well. So, I think before moving on to this particular space, any points of discussion on the case studies?
Participants can ask questions. They can unmute themselves and ask questions.
Okay, or else I will. Now, this is the last section that I wanted to discuss with the forum, and subsequently, then I will stop sharing and we can have a conversation or we can discuss on certain points. Would like to uh, have a discussion to further gain insights. Right. So, whenever we are dealing with a new technology, let me set the whenever we are dealing with new technology which involves inputs or which is relying on inputs which come from various domains. We also need to understand the impact. We also need to look into the ethical, uh, the challenges that are associated with this particular technology, the ethics, whether it fits into by using. We are not, getting into or breaking any laws, or we are not trying to create uh, a difficult situation for any of the groups. So some of the ethical considerations that we need to look into is the biases in AI data, as we discussed in the safety movement as well. This is the area wherein we need to, this needs to be looked into at the initial stage of the development phase. So whenever we are utilizing or predicting to use a particular AI tool, we need to understand the inherent biases that that particular tool has, so that we can build in certain fail safes or certain checkpoints to avoid any impact on the outcome. Ecological consequences, I'm sure AI development and deployment uh, usually might cause unintended environmental impacts. One of the things is when we look into the computing power that is needed to run that particular model, some of the groups might question that we are essentially increasing the amount of energy consumption. And we have come across cases wherein it has been said that do not interact with the chat GPT by starting hi, how are you and all, because it also consumes equal amount of power that might be needed to solve a particular equation. So we might come across certain similar cases. We need to look into consideration around the mitigating those particular things, concerns. uh, Digital divide challenges, unequal access is something that we need to look into. Again, the reason why this particular point comes into picture is because when we look into the sustainability aspect, when we look into the three pillars, we need to have a social equity. So whenever we are saying that we have access to the AI technology, we need to ensure that it is available across the uh, spread of the society, so that everyone gets a chance to utilize it. And there might be certain areas of impact for a particular section which might be skipped if it is not being made available. Uh, we When it comes to security aspect and also the data privacy aspect, uh, whenever we are working with AI tools and developing various models, we need to have ethical guidelines in place for responsible innovation, because when we are dealing with a huge amount of data and the source owns the particular copyright to that particular data, it might be confidential. So we need to be quite uh, strategic in understanding the background and the way that particular data is going to be utilized, so that we are not breaching on the copyrights or the confidentiality aspects as well. Now, some of the barriers that we come across when we are talking about AI is the high cost. Even getting a premium version for a particular AI tool might be quite costly, and the amount of rights or the utilization which is available, or the type of uh, limitations that are put on an open model might be hindering the overall adoption of the new technologies. So high costs is one of the reasons which we need to look into. The infrastructure limitations, again, not everyone will be able to scale up their existing IT infrastructure or the sensors which are being utilized or the instrumentation across the facility to match the requirements of implementing AI tools effectively. So that might be one of the limitations. Third is the expertise. I feel this area is one of the prime points which we can address at the student level, wherein we can create awareness. They don't need to have understanding of how exactly the AI tool is designed and the uh, minute details, the granularities, but having an overview understanding is sufficient so that they can further explore and utilize that knowledge whenever they need to uh, help in adoption of that technology. Regulatory hurdles, we might have come across uh, discussions on forums and policy making groups that we need to limit the availability of certain AI tools because, uh, and also explainable AI usage so that there is a possibility to audit the outcome to check how exactly that particular AI model is deep diving into the data which is available at its backend and ensuring that it is not crossing any requirements bound by confidentiality. Right. Some of the opportunities and trends that are prevalent in the environmental sustainability domain are the integration with IoT and blockchain. The IoT information, the IoT part is about the getting the data, the right amount of the right accurate data from the sensors. And the blockchain aspect is embedded into the supply chain, wherein we can improve the overall logistics and any errors associated with double entries or mishaps. Real-time environmental monitoring. Today we utilize satellites. We utilize data from accurate sensors. We utilize data from uh, various checkpoints, and we are utilizing AI to uh, holistically and on a robust level uh, track and monitor and predict, uh, even in cases wherein some rapid response is needed, so as to improve the conservation efforts. And policy simulations is the area wherein uh, we are utilizing AI tools to ensure or to check uh, what will be the impact of a particular change in the policy or how we can what changes are to be expected if we are having the policy reforms. So that helps in devising or checking or testing the strategies uh, firsthand so that once the policies are announced, we are able to address all the changes on a fast track basis. Right. Uh, Lastly, I think this is just a summary when it comes to ethics challenges and emerging areas. So, one key critical component is the data quality and model reliability that we discussed. Uh, AI models are dependent on accurate and complete data. So, if we are having a faulty data input, for example, in a refinery, we have a predictive model which is quite effectively implemented for the distillation column control. But the temperature sensor itself was faulty, and the data was that was being added was eventually because of the faulty input, the model failed to provide any offset. predictions. So the key takeaway is to also check and ensure that all the data that is being provided is of good quality. It has been vetted, it has been reviewed uh, at certain quality checkpoints, and it has to be done in a cyclic manner so that the model can be updated in case of any variations. Environmental compliance and responsible AI. A lot of times people have a misconception that having an AI system in place is sufficient. Then there won't be any human intervention required, or we can have it in an autonomous loop, which can just provide us inputs as and when needed, and it can act on its own. But that is something which is not the right interpretation. It is a decision support tool, and it's not a compliance shortcut. We cannot completely put the compliance part in this particular case to be managed by the AI itself, because there are policy changes that take place. There might be certain factors which we may have missed when it comes to building that particular model. So it is our responsibility to check and ensure that whatever output or whatever uh, steps that the AI is taking is also in line with the requirement. Last is about the limitations of AI in real world. So it may perform. This is the point again. We are just revisiting. It's about the fact that every model is unique. We cannot have a one size fits all approach. A lot of models are being developed on a granular level. So we need to be quite careful. It is applicable even on the environmental aspect. A model which is useful for predicting uh, the weather patterns in a particular country or a particular region may not be successful, or it might give faulty predictions if it is being applied on a different. So, for example, something that is built on the dry arid conditions to address the weather prediction on the dry arid condition may not be applicable in the tropical zone. Uh, so we need to be quite careful in the industry and the emissions part as well. We need to ensure that even if we are utilizing a base model which has been devised, for example, for a conventional refinery, but we also need to consider the environmental aspects, the feed, the frequency of maintenance cycles that are associated with, and then further improve for your particular case. So we need to look at the fundamental level. And, uh, the idea is to not use it in isolation. So yeah, I think that's the conclusion of the presentation. Uh, the key takeaways are for AI can help us solve the major environmental issues by offering innovative solutions and efficient resource management. But what we need to understand is we need to have the fundamentals clear as to why we are utilizing this particular, what is the expected outcome, uh, why we are utilizing this particular AI tool, and what should be the end result when we are done with this particular exercise. Responsible technological innovation, it runs around the ethical aspect. We need to embrace new technology, but it has to be done responsibly. And we need to ensure that we are not skipping on the sustainable development aspects, or we are not in a way sort of increasing the environmental stress. And yeah, So the third part is securing the future generations. I think we all agree that sustainability has to be at the core of what we do. We need to implement it not just in a professional but in the personal sense as well, and it will help ensure securing the future of our generations to come. All right, that's from my side.
So, any questions, students, participants? Nimish sir, you can ask your question.
Yeah, yeah. Good evening, Pritam. At the outset, excellent presentation, well articulated. I am from the industry. My main question to you is, has there any data or study done to find out the efficiency of the AI usage? That is, AI used during the design or conceptual stage vis-a-vis the actual results obtained during the operation or the commissioning stage. Has there been data?
So we can't be too specific because
No,
we
I understand, but
have
the range. So
yeah,
people understand while, like, as you say,
yes,
when we get a chat GPT results, it's not always accurate.
correct,
You know, the
correct,
same way as a designer or as the same way in the operation, you won't get the
yeah,
100%. But you know, while designing, you need to take that margin if you are aware of
exactly,
the performance. Because you
yeah.
being Worley, being an excellent engineering company, and you have done a lot of projects, I understand. So has there been data collected or any study done to actually see the efficiency of the AI usage? Because we say
Yeah,
AI everywhere, but has it really, how it has performed? That is more important. This is my question to you.
correct. So there are two aspects. I would like to split it into first being on the engineering side, right? We always keep on improving our engineering processes and we utilize AI tools. So there has been substantial improvement in the way we are able to deliver the projects for the customer, which effectively transforms into the overall cost reduction, uh, saving on the timelines. At the same time, when we are discussing with the customers, we have got positive feedback because uh, we being on the engineering side, me being on the engineering side, when I have to speak, we always get insights from the customer when it goes into the operations part. And we have seen positive feedback from the customers that utilizing AI and other tools has helped them improve on the overall operational efficiency. Uh, I can talk about the logistical aspect. It has definitely helped. I know all the key players in the white oil supply chain. They utilize AI models to effectively plan their bulk product transportation. And I have heard quite positive feedback around the operational part as well.
No, Pritam, I appreciate your reply. My question was more respect to not the, I know using models and all, you get better time, cost savings and everything. My question was more with the Worley's experience on the process design. Like during the process design, if you're, as you said, like in water treatment, membrane processes, chemical dosages, which you have tried to, during the envisage during the design stage. And vis-a-vis the
Uh,
actual operation wise, have you got data? I'm just asking you, I know you may not have it, but has any
yeah,
study been done by your team or by someone, just to see the efficacy usage of AI? Because,
correct.
as you
So
said, AI also involves a lot of cost. Using AI involves a
yes,
lot of cost. So has that
yes,
AI really given that benefit overall from the process design? As a chemical engineer, I'm talking about, as not as a, I know cost overruns are taken care of, your deliverables are better,
yeah.
it's, a lot of things are improved. But that's
So
the
I
one
think
part. As a chemical engineer, on the process design part, have you done any study on that? Just one question.
yeah. So considering the current background, Worley is I think any licensor company or someone from that domain will be in a better position because they play
Okay.
with the technology, the pilot plant scale ups and all. From
Okay.
our
Understand. No
perspective,
issue.
I would say we have a very limited technology domain that is part of us, but therein also we are quite in the process of utilizing.
Okay. Thanks. Thank you. I understand. No issue. Challenge. Thank you.
Yeah.
If Maithili, you can ask your question. Aditya,
Yes, ma'am.
yeah, you can ask your
Yes, sir.
question.
I wanted to ask regarding waste optimization. So when we use AI for any wastewater optimization, obviously we'll perform a composition analysis of the waste stream, and then you will say, ki, okay, for so and so chemicals, I want so and so amounts. Basically, you will set a upper limit and possibly a lower limit uh, according to the effluent stream. So my question was, these parameters that we have to this composition or whatever the name of the compounds itself, do we have to input that for the AI, or will it refer to previously established data banks and then will it establish a cause effect relation?
Yes. So when we talk about a particular model, we need to train that model. There are quite a few open models available in the market, in the open source domain as well, which the various scientific groups they keep on updating. So if you're utilizing a pre defined model, then you don't need to start from the basics. But if we are talking about optimizing a particular given process, when we are talking about numbers, then we will have to train it. We will have to provide the operational data or some sample data for it to understand that how exact what are the upper and lower limits and uh, devise the prediction accordingly. So you can build your models by combining the existing models from various groups and further improve the predictability based on the the actual data that is associated.
Okay, thank you.
Anyone else want to ask any question? Okay. So thank you, Pritam sir, for sharing your expertise with us today. Your presentation beautifully connected sustainability challenges with innovative AI solutions, and the case studies, particularly you discussed like energy optimization in reactor or distillation column or AI-based emission prediction, made all the concept that you discussed very clear and relatable. We truly appreciate your time and inspiring insight. Thank you again.
Thanks. Uh, I would just like to make a closing remark. It's uh, See, whatever I have touched upon, it's at the overview, and the more we explore, the more we will able to connect and deep dive into the granularity. So, uh, please feel free to explore, utilize the existing free tools, and that's the only way forward. You can choose a particular case, you can deep dive, and you can discuss with the peers as well. And thank you for giving me this opportunity. It's great to connect with the faculty again.
Thank you, Pritam.
Thank you so much, Pritam, for such an insightful session.
Thank you, ma'am. I will drop.
I'll end the session now and we'll meet again at 6 to 8 session. Thank you.
Participants, do join on time. We'll be starting sharp at 6 p.m. The next speaker is she's from US based. Again, she's our alumna. So please join on time, 6 p.m. sharp.